organized by the Mahaguru Institute of Technology and associated with Pencilbit. It's my great privilege for introducing our today's speaker, Professor Dr. Sailesh Iyer, has a PhD Computer Science, postdoctorate from University of Louisiana Lafayette, USA, public university and ranked among the top 100 universities, and currently serving as the professor and dean with the Roy University, Ahmedabad. He has more than 23 years of in academic and industry and corporate training out of the 18 years of core academic. He is awarded for the Research Excellent Award for year 2021 and 22 by the Ra University and honor adjust of the research scientist at Neuro Lab International under the Dana Brain Health Institute and Iran from the August to 2022 to August to 2025. He has several patents granted, published, and his credit and is involved in the editor for the various book project with the Elsewhere and IGI Global USA, CRC Press Royal and French UK, and Bentham Science UAE. He has been invited as a keynote speaker in the various international conferences held in China, Indonesia, Philippines, Saudi Arabia, Ukraine, and Italy and India. The hardcore academician and administrator, he has an excellent in corporate training and deliver 150 exposed speech talks in the various AICT sponsored STTPS and ATL FDPs and reputed university government organized workshop oriented and refresh course organized by the HRDC Gujarat University. The research cooperations include the reputed publications, track chair at ICDL AIR 2022 Springer, Italy, an IC Soft Camp of 2022, an IEMI 2020 Springer, ICRITO 2020 IEEE, and ARISE 2021, FTSE 2021, and TCP, member of various reputed international and national conferences, and reviewer of international journals like Multimedia Tools and Applications Springer, the Journal of Computer Science, Scopus Index, and International of Big Data Analytics and Healthcare, IGI Global. The research-based topic in the various university and conference is additional to the guiding the research scholar as a supervisor. He is also being invited for the judge for the various event and competitions and examiner for the reputed university in the Computer Society of India lifetime member, and also serving as the managing committee member and SCI Ahmedabad chapter 2028 to 2020. Welcome you, sir.
Thank you very much for inviting me as a resource person for this excellent FDP. Actually, I would just like to congratulate the organizers for timing this event in such a manner that we are in the starting of the session, academic session, and equally the faculties are needed to boost up their career. They need to have some kind of enhancement in their learning. So I think so this is the right time for the session to be organized and the FDP to be organized. Now, with these words, actually, I just want to share my screen. I hope the screen is visible.
Yes, sir.
Yeah, fine. Now, this is actually what I would be talking about today. I would be just trying to reach out to academicians because research is not going to be just an academic related exercise. It's also going to be an exercise where we are going to inspire students to undertake some research projects. We are going to inspire people. Suppose if you are a guide, you need to inspire the scholars for selecting the topics. So there are various areas in which we can work on. One of these areas is artificial intelligence, which is very much well known. And second, I would like to say is robotics. Now, if you combine both of them, it's going to become a huge domain where a lot of research dimensions are there. So I would just like to give the agenda for today's session. First, I would like to focus upon UN Sustainable Development Goals. Second, I would like to focus upon pan India smart solutions because we are talking about smart cities and villages. So, how we can, I mean, which are the domains where smart cities and smart villages are required to make India smart? So, that I would like to focus upon. Sorry. Then, humanoid robots, their application types and research areas. AI, image processing, and humanoid robots. Because as I told you, that robotics is not something which can be done independently. You need to have a collection of different areas collaborating with different areas. So AI, image processing, humanoid robots, and IoT. They are going to play a major role in a combined way to give you solutions. My area of research, basically postdoc, was in medical image processing. So I would like to talk about medical image processing a little bit. Then variable data processing life cycle, which is a very huge market and a lot of research challenges are there. And there is a huge research going on in healthcare, particularly glaucoma-related, lifestyle-related diseases. And there are a lot of gaps in research that I would like to explore. Then in agriculture in particular, we have image processing, AI, and robotics, which can be used in a combined manner. So that I would like to explore a little bit. And then which are the use cases of AI and the research innovations that are possible. So this is the broad agenda that I would like to uh, cover in today's session. Now, what is the market size of AI and robotics? Now, if you just see here, I mean, this is an estimated organized market, right? There are a lot of unorganized um, players in this particular domain. So if I just talk about the organized market, then market size is expected to show an annual growth rate of 24.80 between 2024 and 2030. So in this 6 to 7 years, we are going to see close to 25% CAGR growth, resulting in a market volume of US dollar 64.35 billion by 2030. So that's a huge uh, I mean, increase that is expected. This, as I told you, this is an organized market. In India, we have a huge unorganized market, which is going to cater to a lot of challenges. So we are looking at this domain also. Global comparison, the longest market size will be in the United States. So US is going to be contribute more compared to other countries, but India is not far behind. Now, if I talk about UN Sustainable Development Goals, now it's called SDGs. So there are 17 Sustainable Development Goals proposed by UN, and this is very fundamental. That is what UN is saying, that we need these 17 Sustainable Development Goals to be implemented in each of the countries, that whether it's a developed country, whether it's a developing country or underdeveloped country, we need to work on all these 17 Sustainable Development Goals. So out of these, some are directly related to technology, where technology can be used, where we can do research and we can give better solutions. But not all we can cater to. But I would just like to focus upon a few of them. Like first of all, there are apps for this no poverty, where people are getting job related options so they can get employment. The zero hunger is one solution which has been already provided on various platforms. Like there are various apps in India also which actually encourage you to donate your food from restaurants, from your household. If you just have sizable food amount, suppose I have a party, I've organized a party at my house or at some location. Now, I have estimated that 100 people will be attending, only 50 attend. So, balance 50 people food is going to go waste. So, rather than wasting it, I would like to contribute towards the hungry people so that they can have this food. So, there are a lot of players who are helping out in this. So, zero hunger apps are there which actually help in this. So, IT can be promoted there also in a particular domain, but I think so a lot of work is being done there. Good health and well-being. Now, this is an area where I think so post-COVID, there have been a huge spurt in such kind of uh, good health and well-being cases. Where I would like to tell you that since 2021, There are more than 1 lakh startups in just healthcare industry, and they are all technically driven. So this is a huge domain where I think so technology would be used, AI, robotics. In healthcare, it's going to be a big challenge on how to promote automated healthcare in India. So that area is my favorite area where I believe that a lot of work can be done. And we need to contribute as academicians, as researchers, as mentors, as PhD supervisors. We need to contribute towards this by guiding students and faculties alike for this. Quality education is one more domain where a lot of work can be done, because I have done a project, actually it's currently going on, which is on adaptive learning using humanoid robots in education. So what I found is that in particular sector, now if I say that I've taken an example of Gujarat in 2017 or 18, it was there 18 rather, it was in the newspapers, Times of India. They had done a survey of villages, schools in the villages, government schools. They found that students were not able to answer basic questions. Suppose if a fifth standard student is not able to do basic maths calculations, no basic science concepts. So the English was also poor. So looking to all this, it was decided that there has to be some kind of a, what were the reasons for that? That was discussed. So first reason was that most of the primary teachers are given a lot of work related to government, like suppose administrative work. They have to go to household, collect some data. All these things is extra work that is given by the government, for which the academics is suffering. And there are very few teachers. There are in many of the schools there is only one teacher available in that school. Right now, that is not actually the count cadre that should be there in the schools. So looking at all this, it was not the fault of the teachers, but it was the fault of the administration, how they were dealing with this. Most of the states, this is the thing, that government school teachers are being used in all other duties rather than academics. So their academics is suffering and students are suffering. So looking at this, actually, we prepared a project proposal and we have applied for funding and it is under consideration. Now this project will be implemented where we are proposing humanoid robots which are actually just acting like teachers. So they can be substitute to teachers for this particular exercise. Now, this is going to be a huge project, and when I looked at these humanoid robots, the cost I got from many of the players was starting from 3 lakhs to 30 lakhs. This was the range in which I asked for the proposals. Some of the robots are having basic capabilities, they are available for 3 lakhs, but then can school education afford these teachers? So again, we need to look at cost cutting. So there was a certain experiment done by one of the school teachers in Tamil Nadu. He prepared a humanoid robot out of e-waste, and that was prepared at 50,000 rupees. Now it had some basic facilities inbuilt into them, but 50,000 is a better price. Now if it is going into bulk production, then maybe the cost may come down still. So I think so in quality education, a lot of work can be done and we can contribute towards that. Gender equality is not such a major concern, though we have some apps which are supporting them. So I don't think much can be done in that. But yes, people are free to work on that domain also. Clean water and sanitization. This is one area where a lot of work is being done. Uh, we need to clean water. So here AI, IoT uh, can be used to good effect. Affordable and clean energy. Again, this is one emerging area where we are looking at climate change, we are looking at energy, climate action, and 7 and 13 I would like to combine. 8 is one area where decent work and economic growth, that is also actually subject to people behaving in a particular manner. So I don't think that would be much of a challenge for us in that particular research domain. Industry innovation and infrastructure. Here, a lot of in 9 and 11, these are areas where I think so lot of research work is going on. And digital twins, whether it is digital twins, one of my recent project of digital twins is just currently in the market, and it would be published by I think so September 24, it is with Elsevier, Digital Twins for Smart Cities and Villages. So that book contains 27 chapters from leading authors all over the world. So this would be a good book on that. So a lot of work is being done in this domain and a lot of work needs to be done. So if we want sustainable cities and communities and we want to work for manufacturing towards industries. Responsible consumption and production. Now, this is one domain where I think so industries need to look at it in a bigger manner. Life below water. Again, lot of work is going on here. Again, technology needs to be used. AI in particular, image processing in particular, because we are going below water. We need to capture the images. We need to capture the content, and then we need to work on it. During COVID, actually, when there was lockdown, lot of species which we thought that water species were extinct actually evolved and came to the shores. So we are able to see a lot of new species which were not actually, we thought we were not able to track them, or they were extinct, that we came to know. So a lot of work can be done for life below water, life on land, peace, justice. Of course, we need to have a cyber security mechanism which is very strong. We need to have a justice mechanism which can, because now everything is going to be online. Most of the uh, transactions are online, so a lot of things would be related to justice where cyber crime or cyber law is involved. So that is a domain where I think so we can contribute a lot. And partnership for the goals. So these are 17 sustainable development goals. Now I would like to come to basically India, where we can look at pan India smart solutions. So according to government, these are the thrust areas of government for giving smart solutions. So whether it is a smart city or a smart village, these are the areas where we need to focus upon. So first is e-governance and citizen service, because citizens are always complaining that we are paying tax, yet when there is rain, the roads are not proper. There is a lot of waterlogging. There are a lot of potholes on the road. So all these issues are there. There are other issues also which the citizens are facing. So can we provide such a solution, automated solution for e-governance and citizen services, where citizens don't have to go to any particular office to complain? So there are some governments which have done this, some state governments which have implemented this, and some are in the phase of implementation. But a lot of work can be done in this domain. So e-governance is a big domain which I think would be governing in the next 5 to 7 years. Because by 2030, if we want at least 100 smart cities in India, we need to look at this in a big way. Second is waste management. Now, this is a huge challenge for us because right now everything is being done manually. When I talk about manually, what I mean is that whatever waste collection is taking place, garbage collection, that is being done on a manual, by manual. Like even though the suppose in uh, Gujarat we have a particular, in Ahmedabad we have Ahmedabad Municipal Corporation. So those vehicles are coming. Those vehicles contain a few people inside there. They are not having any kind of safety wear also. They are not having, some may not wear gloves also. They are not having protective gear for them. They are collecting the waste, and that waste is in the van where they are standing. That means they are quite exposed to a lot of hazards. So what can be done about that? So can we have waste collection mechanism where it is automated? Can we have humanoid robots collecting the waste? Can we have autonomous vehicles so there's no dependence on any kind of human being for collecting the waste, and they are not exposed to any kind of hazards? So these are all areas where we can look at waste management. Once the waste is collected, can we do recycling of it? Can we have a reduction or recycling of the waste that is collected? E-waste collection is also an important challenge. So are the people equipped right now? The people who are collecting the waste, are they equipped enough to separate the waste? Because when all the waste is collected together, it starts from the home. We don't have separate dustbins. Normally, even though government has given, some people are not using it. They are all putting all the waste into one dustbin, whether it is wet, dry, whether it is e-waste, everything is going into one dustbin. So that is collected by the authorities, and then again there are challenges in separation of that. So can we have some automation in the separation mechanism? Can we have the automation in the collection mechanism? Can we do automated recycling by robots where human intervention is not there? So these are all challenges, I think, so which are budding research areas. So these are all the topics that I've listed here. Water management is one more thing actually in Save Water campaign is going on. By 2025, it is said that if we use the way we are using the water right now, then it can lead to a lot of shortage of drinking water. Pure drinking water will not be available. Even water for our daily use will be restricted. So we need to have water management. So we have smart meters. Now, how these smart meters can be implemented and managed, how the cost can be brought down. A lot of research challenges are there. Now, if suppose I am there in my society, uh, if I want to individually check how much water I have used, so society can monitor that also. Accordingly, the billing can be done. Suppose my house is using only less water, then my bill would be less for the common facility also, for the water also. Smart meters can be implemented for that. If suppose my house is locked or whenever I want to monitor suppose I'm in office, nobody is at home, but still there is some kind of water consumption being showed through the meter. That means there is some leakage in my house. So that leakage needs to be identified and preventive maintenance need to be done. So in that also, this can be very useful. Water quality monitoring also, what kind of TDS we are getting for the drinking water, what kind of water facilities we are having, whether we are getting usable water or contaminated water, all this can be monitored very well with these kind of challenges. So I think water management is going to be a huge challenge and a lot of research should be done in this area, which is not currently being done. Then we have energy management. In with water, the next part is energy. So smart and meters and management, renewable sources of energy, energy efficient and green buildings. So these are the areas where I think so energy management can be done. Now we need to have green buildings where we have solar energy or renewable sources of energy being implemented. So there a lot of cost effective options need to be given. So their research trends are enormous. Then you have urban mobility. Like we have a big problem of parking. Where if you go to a city, in villages still we are having that much space for parking. But in cities, if we look at, especially the metro cities, we have a lot of parking problems. So we don't find space for parking, and people are very impatient. They park at a particular location. It may happen that within 100 meters there's some parking space, but they don't know about it. So can we have parking solutions where we can provide such alternatives to the consumer? So this is something which we can look at. These are the challenges which I'm talking about. Intelligent traffic management. In most of the cities, some roads are particularly choked up due to traffic which is there in a huge number, and during peak hours, it takes close to 2 hours also to clear the traffic. So can there be intelligent traffic management patterns? Yes, because if I am supposed to go through some other road, my location is different, then if it can be diverted to less traffic zones, then that would be more favorable for the climate, for the environment, as well as for my time savings. So this is something which we think can be a huge challenge going ahead. Integrated multimodal transport, that is also one huge challenge. Again, we need to share the transport. So can there be some kind of research done in this domain? So that can also be one of the huge challenges. Skill development centers, I think this is going to be a huge challenge because we are dealing with, if currently we are going to produce the kind of candidates that we are producing in the market, we'll not be having skilled people who are worth employable. Skill development centers need to be worked upon. Incubation or trade facilitation centers that already government is working upon, and telemedicine and teleeducation. Again, here I feel that humanoid robots can play a very important part because there can be alternative to doctors in certain rural hospitals or certain hospitals where doctors are not available, experts are not available, specialists are not available. The humanoid robots can work on the instruction of the expert doctors. So I think so. These are pan India smart solutions which we are talking about. Now, if any questions are there, I would like to just interrupt in between for a short, maybe a question answer session of 2 or 3 minutes, and then we can again come back. If anybody has any question, I have basically highlighted these domains because these are the domains where maximum research would take place in the future. In India, in particular, we know the domain, we know the demographics, we know the challenges. So it will be easy for us to work on these domains because these are all common problems which all are facing. So if we are able to give some kind of new model, research can be done where we can suggest some kind of a pattern and we can come up with solutions, then that can be very effective. Now, this is what smart cities are all about. And in that, we have smart environment, smart health, and smart governance. So, these are the three major issues which we are dealing with. Now, when I talk about smart environment, what I mean is that we need a clean and green environment, which was already covered in our smart city fundamentals. Then we have smart buildings, smart water, smart integration, smart energy, smart public services. So these are some of the challenges or some of the areas where we need to work upon. And I think so these are going to be the areas of research where it's going to affect the common man, it's going to affect the government, it's going to affect all the people around us. Now coming to humanoid robot application. Now humanoid robot is not that tough as it seems, but there are some applications which, I mean, basically where humanoid robots are effective enough is where you have lot of places where humans are right now exposing themselves, and when these humans are exposing themselves they are having some kind of issues. Like suppose if I say that if I am a human being, I am exposing myself to a particular domain, like I am in a coal mine or I am in a mining field, then it leads to a lot of issues. So the health workers, they are exposing themselves to a lot of risks. So in such areas, I believe this can be done, and humanoid robot applications can be. I mean, these applications can be used. So mining, rescue operations, military, nuclear places where nuclear operations are going on, industries, uh, astro navigation, that is there also a lot of humanoid robots can work. Education, as I told you, cognitive applications are there, home, medical, entertainment. Lot of such applications are there which can be used on the security domain also. So these are some of the humanoid robots applications. Before going deep into humanoid robot, I would just like to clear some definitions here because these are some of the terms which are being used in robotics. So collaborative robot is one where a robot is specifically designed for direct interaction with a human within a defined collaborative workspace. So this is again a definition which is very important. Collaborative robots are the need of the hour. Robot is specifically defined for direct interaction with a human within a defined collaborative workspace. Now, what is a collaborative workspace? Safeguarded space where the robot and a human can perform tasks simultaneously during automatic operations. Then there is a collaborative operation. I've just tried to bifurcate it and make it simple for you to understand. So collaborative operation is a human robot interaction state in which proposed design robots can safely operate or work in direct cooperation with a human within a defined workspace. Then you have intelligent assist device, which is a smart lift assist device, generally not incorporating autonomous operation mode. So we can use intelligent assist device for certain specific applications. So such kind of robots, they are also part of humanoid robots. Cobot is an abbreviation of collaborative robots and synonymous with intelligent. So it's a hybrid model of both intelligent assist device as well as collaboration. So what are the benefits of humanoid robots? Robots are very much excelling at simple, repetitive handling tasks. So wherever mechanical jobs are there, where you believe that normal people do it and they are mundane tasks or they are tasks which are going to be repeated again and again, where there is no extra innovation involved or no thinking mainly involved, there robots can excel. Robots were initially made for that purpose to replace human beings in these domains. Humans have unique cognitive skills for understanding and adapting any changes in the tasks. So, just hello, hello. Hi. So, अभी मैंने start buying this car. आपके पास है तो शायद प्रोडक्ट का तो शायद बना फिर भी आप शायद की भी नहीं sorry for the disturbance. Actually, so like I was talking about, uh, the combinations of humans and robots, they can greatly improve the performance because we need to bifurcate where humans are involved and where robots can be involved. So this kind of collaboration is going to take place. This can be taking place where expert areas are also there. Suppose like in medical facilities or healthcare. Now, there may be many people who may be experts in particular areas, surgery, etc. Now, when humanoid robot is doing the surgery, they've been trained for that, but still they need to be supervised. So they are supervised by the doctor online, and then the surgery is done. So this is something where human robot collaboration can take place, right? Uh, Safety of human is an area where I think so robots should be used on a regular basis. The collaborative robots should have some of these features, that is safety rated stop monitoring, because robot cannot be given a total free and there should be some monitoring and we need to stop at some stage. So that also facility needs to be given. Hand guiding, that is teaching by demonstration, should be given. Speed and separation monitoring should be there in the features, and power and force limiting. So these are some of the features which should be there in. As I told you, these are some of the key robot functions. Operation in automatic mode with a person in the collaborative workspace. When the person is acting, the robot is reacting to it. Incorporating specific safety design features to protect the person from injury. So this can be health safety or health hazard can be guarded here using robots. Can have both autonomous and collaborative phases in automatic life cycle. So this can be done in a collaborative manner. So we need to do all this. I'm not going to much of the technical details because I'm going to focus upon the areas where we need to work on the research and which are the certain innovative devices which have been manufactured up till now, which have been made up till now. So, but we need to have some kind of safety features for safe velocity monitoring, safe workspaces, and safeguarded zones. We have a lot of movies where robots can turn destructive. So that safety needs to be provided. Safe collision detection, safe force monitoring, safe tool detection, and safe switching of states. So these are all some of the safety features which you need to incorporate in the. These are the forms of human-robot collaboration. If you say that robot workspace and operator workspace is there, slowly it is increasing and human-robot collaboration is happening, where humans are also involved directly and robots are also involved. So this is the shared workspace which we are talking about. So as you go ahead, the human robot collaboration is देखिए इसको बनाना दोनों बस एक ही जगह डेट मंगा लीजिए 8 दे रहे हैं so this is how a humanoid robot looks like how it actually is constituted and what it is made for. So they are used for uh, finding a moving object, and intelligent vision should be there. Avoid walking can be avoided, or whenever required, it can be again demonstrated. Edge detection and shape recognition should be there. Color recognition should be there. So all these are the features which should be there in a humanoid. So this is how it is made. Now the whole challenge here is that this is quite technical. Now, can we reduce the cost of a humanoid robot at any stage? So that is a major challenge. So how can we reduce the cost such that it can be used in bulk in various areas and it can be managed? So this is how we are looking. Now this is one more application where these are not regular police; these are robots which are acting as a police, and they can be very effective. Like we have faced a lot of stone pelting incidents, lot of mobs. To disperse mobs again, we are at a risk of a lot of things. So human lives can be endangered here. So we can have humanoid robots, humanoid police who can behave as a law enforcer, and we can try. But again, this needs to be done very effectively, because if the excess is done on the mob, then that can lead to a lot of loss of lives of the people who are protesting also. So we need to look at this in a different manner altogether. So here I think so humanoid police, humanoid robot as police can be very effective. Pizza assembly point, this can be an automated process completely where robots can be doing this. We don't need human beings over there. This is being used right now. AI powered hotel solutions. Now, this is what is happening here. We don't have people here. Instead of people, robots are using AI and effectively giving you all the solutions. You can do all these tasks through AI powered hotel solutions with minimum interaction with humans. You can schedule your lunch or dinner, order meals or drinks. Today's special recommendation now based on what you have done. Like suppose it's like you have certain what you have ordered before. Based on that, it will give you recommendation that this is what you can order. So we can look at that. Answering critical queries, uh, recommending sightseeing and visits. So all this can be done with the help of AI-powered hotel solutions. This can be very effective. So here, humanoid robots can also be a part of hotels, starting from giving uh, recommendations at the reception to giving you advice to wallet parking at the security desk. So all this can be humanoid robots which can do these tasks. Now, AI-powered robot has assistant for hotels. This is what I said, that valet parking, guiding, everything can be done with the help of this humanoid robot. So if you can give the car keys to this humanoid robot, they will park the vehicle at just like what a human being is doing. So this can be a very good area where we are looking at. I mean, schools also, like this is a particular school in Bangalore which has implemented this, and on these models we are trying it for certain rural areas. where we have humanoid robot, just like this person who is standing with a tie is actually a gentleman who is a teacher in the school, and the other side is a humanoid robot. She is actually very much accepted by the students, and they can not replace teachers, but yeah, they can supplement teachers wherever required. They can do a lot of tasks which teachers find it mundane and they want to pass on to other people. So adaptive learning can also be used using humanoid robots where we are looking. So enhancement features, we can have sensitivity in humanoid robots, distance sensing, and voice interpretation. These three are the challenges where we can enhance the features. We can provide it, but sensitivity is a domain where a lot of work is currently going on. Human sensors and sensitivity is a domain where work is going on. Distance sensing, again, vision or radar sensors. That's also a area where a lot of work is currently in progress. And voice interpretation, how we are based on the voice, the control can be done of the robot. So that also can be. Now, if I go step by step, I'll just skip this. I'll go a little bit fast here. Safe operational stop, like these are just some kind of mechanisms which have been dealt with, and what are the steps for this. We want to have advancements in robot and sensor technologies or standstill monitoring. So during the stop state, the drives remain under control. That means the brakes are not applied, but still they are safe monitoring. And until a robo restart is activated, it is safe. Once it is activated, then it can be used for it. Makes it unnecessary for the robot to stop completely for manual loading and allow it to start moving quickly again. So again, safe operational stop is one operation which is very much important here. Safe protection zone should be there, wherein robots are not going to be within such areas where human beings are there. Robots can be independently operating. So this can be safe protection zones where these robots can function. And there can be hazardous risks also of health. So we don't require any human being in that business. Intelligent manipulators where they use their logic and they are programmed for that and they can give you solutions also. Radiation surgery, now this is very much precision based surgery which is performed by humanoid robots. So humanoid robots and devices and machines can play a very important role in radiation surgery. So this is one domain where I think lot of precision and lot of you can say this is a part of medical imaging also. I'll just give you some examples that in medical imaging, actually, when we are talking about radiologists taking images of different parts of the body, like suppose if we are doing a brain scan, etc., then that brain scan earlier used to have devices which are very heavy. Now we can have a small helmet sort of thing which looks like a helmet, which is a head scanner actually, which is weighing less than 1 kg. The earlier device was weighing 430 kgs, and it required a lot of precautions to be taken. You should not move your head when you are inside the device. Now, this can allow a lot of features. So such devices are going to be the future. So this is where I think so research in healthcare is going to change the whole world. So radiation surgery is being done by humanoid robots right now. Particle therapy, again, this is the treatment room. In India also soon such technology would be coming where we are going to play a very important role. Angiography is being done with the help of such devices which are controlled or which are robotic in nature. Hippotherapy, again, this is one therapy where humanoid robots and devices are involved. So this can give you better precision and accuracy compared to what we have in normal doctor-driven operations. Entertainment rights systems, again, humanoid robots can play a very important part here. Safety features also. Biological cybernetic research here also. I mean, this can be devices can play. These are all robots which are very multi-purpose robots which can do a lot of tasks. Motion pictures. Again, we deal with all these motion pictures where robots can play a very important role. Collaborative application development where minimally invasive surgery is taking place. Now, this is totally done by a humanoid robot where we don't have intervention because it requires a very high degree of precision and it is guided by the doctor and it is done by the humanoid robot. So, again, lot of precision, lot of technology going into this. Physical rehabilitation, again, we can use humanoid robots for physiotherapy and rehabilitation purposes. TV news, again, now we have seen anchors are all mostly robots. Some of the news channels in India also, when weather regarding forecasts are there, it is being done by a humanoid robot. Uh, we have one of the UAE has given the citizenship to one humanoid robot. Um, so these are all the changes that you'll be watching here. I'll just try to show this video here. Just give me a minute. I'll try to activate this. I think so now. I'll just try to. I'll just copy this. I think so there is some issue in the video. Just try it on the browser. So I just want you to see this short video. I hope the video is visible. So this is Uka actually. It's And like then so as you see that I mean technology can play a very important role. Just give me a minute. So actually, there are some lightweight mobile platforms where humanoid robots are quite lightweight and they actually do the work of mobile navigation systems. They are autonomous mobile navigation systems. So Kuka is one big example of that, and it is being effectively used in a lot of applications right now. So in research and education, also a lot of such they are called actually bots. I would like to say they are small robots who are acting also as some bots which can actually give you a lot of information. So this is a standard platform which enables researchers to focus on their research, and there are various kind of shapes and devices form that it can take place, and they can work as uh, some kind of open source software library also. They are really programmable also. They have open interfaces. So a lot of sub benefits are there in research and education also where humanoid robots can play a really important. There are service robots which are particularly for some service tasks they are being used. Then humanoid robots, these are particular examples of humanoid robots used in Germany. DLR Jason, this is a humanoid robot, and they are doing particular specific tasks with precision, giving the output. Wearable robotics, this is where actually robotic limbs are there, which can help you do a lot of things, which otherwise you cannot do with your regular limbs, etc. So robotic limbs are also very effective. These are some mobile military applications where this is a humanoid robot, and this can actually, as I told you earlier, also as police in military, also like when we are doing some secret operations, at that time these humanoid robots can be very effective, and loss of lives can be saved, because it can go to such an area where they cannot be easily caught, and they are small in nature. This is a bigger version, but there are small robots also which can work. And now they are being replaced by mini drones also. So mini drones can also be combined with robot features, and a lot of things can be added into that. So these are some of the applications in mobile military applications that we can use. And industrial robots are very much prevalent in India. We are still at a very starting stage. This is why I feel that robotics market is going to be huge in India. Robotics and drone market combined with IoT, AI, image processing, cloud computing, all this is going to rule the world. So I think there are a lot of options in this domain for research. So when we talk about such kind of robots, like I had done such an experiment in one of the tile manufacturing companies. Actually, ceramic manufacturers are there in Modi in Gujarat, which is almost 250, 260 kilometers from Ahmedabad, close 100 kilometers from Rajkot, 95, 90 kilometers from Rajkot in particular. So this is an area where which is well known for ceramic manufacturing. That is, export a lot of ceramic tiles are being exported abroad, high quality tiles, and that in bulk production is taking place. So we had such a project where we had involved our students also, and it was an image processing AI based robotic project. Wherein what they had almost semi automated their operations, but when the tiles were coming out through the conveyor belt, then they need to be classified into whether it is a particular uh, high quality tile, or premium quality tile, low quality tile, or C quality tile. So C quality tile they used to sell in the market for a lower rate. High quality tile, higher quality tile they need to export outside. So they needed to classify that. Now when the tile was coming out of the conveyor belt, uh, it was to be done in few seconds. Hardly not more than 30 seconds were available for the conveyor person standing at the conveyor belt to mark whether it's a premium quality tile. So with the naked eye, they were doing this. So we were asked to automate it. So as a part of ESR, Education Social Responsibility, we took this project and we started implementation, wherein we had two versions. We had one humanoid robot version also, and we had offered them a version where you can have an image processing based AI solution. We have a camera at the top, and that camera actually is a high speed camera which captures images very fast from different orientation angles. And we had already fed the images of perfect different quality of tiles, and it used to compare these images, and they used to decide whether this was a premium tile, average tile, or a C type tile. So accordingly, the conveyor belt was classifying into separate domains. So this was an AI-based image processing solution which we had used. But there was one more extension which was required, that they said that we don't want people, but then we also want somebody to monitor. So we had this monitoring being done combined into these operations with the help of a small humanoid robot there, who was actually classifying also and seeing to it that this is being classified in a proper manner. So this kind of project we have executed, and it has given good returns because they were saving a lot of manpower, and a lot of errors were being solved. Because I mean, if I talk about errors, then there can be a lot of human errors in because they were looking in 30 seconds, they were identifying the tile to the naked eye, and 8 hours they were standing constantly there. So it was very taxing on the human beings who was doing that work. So accuracy was a question mark. So because of this, actually, this solution would be more effective. These are collaborative humanoid robots with certain payloads. So they have been given in such a manner that these are industry robots, which have been classified here. So they can be used for multiple tasks, and human being intervention is very less. These are soft humanoid robots. Now, the function of this was that in Japan, in particular, and China also in some places, actually, we found that there were some soft humanoid robots which was being given for elderly healthcare. That means they also acted as uh, caretakers for these particular. Uh, they were soft because actually, if at any time, if they even bang into any elderly citizen, it does not affect the elderly citizen because it's a soft humanoid robot. So this humanoid robots took care. They spoke just like real, I mean, just like their granddaughter or daughter or son speaks, and they care for the elderly. So elderly care robot can be classified as a soft humanoid robot here. They can be used for various applications, but in Japan they are being used in particularly this domain because in Japan the elderly population is much more, and they don't have people to take care of them. So this is one important solution which I think can be used for Indian environment also. Now, how we can go about this, how we can make it multilingual, how we can make it suited according to the accent of the Indian surroundings. Because in India, what happens is that we have different zones. The main challenge is that if you have a humanoid robot talking to the particular people. Now, if just like right now, Google, if we are searching for a location or if we are following Google directions, the accent is not typical Indian English. It's more American English. If it can be accent can be localized. Like suppose if any Marathi is asking for interactive Marathi people we are interacting with, then the humanoid robot should be having that Marathi accent. So that is something which has to be worked upon. A lot of research on natural language processing combined with humanoid robot. This needs to be done. These are elderly care, different versions of elderly care robots, as I told you. This can just behave like normal human beings. So these are some of the 10 robotic trends 2024 that are taken from different sources. So first is here where we have autonomous mobile robot, then we have intelligent robotics, then we have robots, we have robotics as a service, robotics cyber security, drones, Internet of robotic things, humanoid robots, automated guided vehicles, and assistive robots. Here, automated guided vehicles are a big challenge for India because in India, traffic sense is minimal. You will agree with that. Like I was just interacting with one of the scientists from Japan during one of the conferences. He told me that in Japan they have such a system that if somebody is showing the indicator to the left or to the right rather, and trying to move the steering to the left, then the steering will be locked. It will move to the right only. It will not move to the left. So similar mechanisms can be implemented in India where people are not that uh, traffic savvy. People are not that smart. They are not following the rules. So here, automated guided vehicles can be a huge challenge. Cyber security can also be a huge challenge. Drones are a challenge. So three or four areas out of these 10 are particular areas where in India a lot of research is required according to the demographics of it. So I think so these are areas, budding areas where a lot of work can be done. Now, I would just like to focus up a little bit on image processing as I have worked on those domains. So I think image processing and AI can be combined together along with robotics to give you a lot of solutions. So first, before going into image processing, I would like to focus a little bit on how this image processing is working. So there's a image processing block diagram where an input image is given, the image is acquired or acquisition is done, then it is enhanced because the image may not be having that kind of clarity, that kind of features that is required. So that image enhancement is done. A lot of tools are available for that. Then the image rotation is done or orientation is done. Then morphological processing is done. Then you go for image segmentation where you're changing it into different segments. Representation and description is done. Then you are going for object recognition, and then the output image is being generated. So these are all the stages of how the image processing is being done. Now this is medical image processing in particular because as I told you that I am working on medical imaging or medical image processing as such using AI. So acquisition digitization can be combined into one form which is called formation. Enhancement is one another form where calibration, registration, optimization, transformation, and filtering is done of the image. So that is a part of enhancement. Then comes the visualization stage where you have surface reconstruction, illumination because the lighting may not be proper, so you need to give proper visual effects there. Shading may not be proper, and the display features may not be proper. So that is done by visualization. Feature extraction is done. This is the analysis part. That feature extraction we are going for segmentation, classification, interpretation, and measurement. So this is a part of analysis. And then we have management where we are compressing the image, archiving the image, retrieval, and communication. So this is broadly what we call as medical image processing in a nutshell. Steps of medical image analysis. Again, as I told you, the same steps almost, but little bit changes here. Image acquisition is done, then digitization is done, pre-processing is done because we need to look at various areas where processing needs to be done before actually we start the segmentation part. So pre-processing is done where a lot of missing features are extracted and they are tried to be incorporated into them. Or certain places where we are looking at certain things that are extra which needs to be removed from the image. So that can be a part of pre-processing. Uh, then segmentation comes. After that, the main thing is feature extraction, where we have shape analysis, texture analysis, and parametric analysis. So this is being done here, feature extraction, then classification, and then interpretation. So this is basically how medical image analysis takes place. Now, if you go a little bit more detail into it, we need to give image annotation and labeling best practices. So we need to label objects in their entirety, what these objects represent, because in certain cases we need to highlight the certain parts of the image particularly. So that needs to be labeled properly. Full, fully labeled obstructed images, objects that need to be identified, and that can be removed from the image. Also, obstructed object needs to be removed so that it can be clearly seen. Maintain labeling consistency across images using specific label names. So all these are parts of the labeling practices that we use. Provide clear guidelines, provide define annotation tasks specifically, and then test reliability at a small scale. So after this is done, we can go for using the image in the entirety. So that was about some brief idea about what how image processing is working. Now we are going for the variable data processing life cycle. So when we talk about variable data processing life cycle, we are talking about again pre-processing. Once data is collected, pre-processing is done, data transfer is done, computing paradigms are there. Data pre-processing is done, data storage, and then ultimately this cycle goes on. So what is this wearable data? As I was talking about earlier, I was talking about MEG scan. So this is a device, this is a portable MEG device which has been developed where a new type of sensor can be mounted directly onto the scalp in this form with the help of a 3D printed helmet. Now 3D printing has came into the limelight very soon once COVID started because COVID gave a lot of uh, business prospects for 3D printing. So 3D printing become a big industry once COVID was affected us. So this is an MEG scanner on the right side. Actually weighs more than 450 kg normally, and sensors need to be kept at minus 269 degrees Celsius. And cooling equipment made them quite bulky. And once the patient is inside the machine, his head has to stay still or he has to stay still. So it was very difficult for elderly citizens and small children to go through the machine because it was very, they had to stay still, and if they actually just move or if they have some magnetic field affected equipment or any kind of device with them, it would be very risky for them. So this kind of a device was being used earlier. Now we have new type of sensors that can be put directly onto the scalp. It weighs less than 1 kg. The patient can move around uh, inside, especially the design room. That so there is no such kind of boundary that patient cannot move with the this particular helmet, 3D printed helmet on. So these are the changes that have occurred, and this has made it very effective. But the only problem is the cost has gone up. Now, what we have to work about in India healthcare industry is how to reduce the cost and yet maintain the features. So that is a research area that I think so is going to be the challenge. Now, this is a detailed diagram of it, how the helmet is connected to the head here. So we have a lot of internal devices here. We have sensors, we have magnetic field being cultivated. Custom coils are there on the wall. So right now, wearable device market is huge, and this is an area where I think so. Lot of challenges are there, and a lot of research domains are there. Like I would like to say here that most of the wearable devices are of this nature, like glasses, that can be various headgear, mouth guard can be there, clothing can be there, headset, armband can be there, wristwatch. A watch is a smart watch which gives you a lot of things. Strip can be there, which can be on the hand or on any particular part. Belt can be there. This is a smart belt. Shoes can be there. A ring. So all these are devices which are wearable devices, which are being used for specific purposes, giving specific functionality out of the data. Now, this is AI in processing of medical signal data. So here, as I told you that hearing aids are there, smart clothes are there, all these things are giving some kind of data and transmitting some data. And through that data, we are getting all the details on our cell phone, and we are getting the ultimate decisions which can be managed here. So we are able to do it in a very effective manner. Again, the data stored is on the cloud, which can be retrieved very easily. So we don't have that much big storage device requirement. But yeah, cloud requirement is there because this is going to lead to a lot of data being generated on a regular basis. So this can be monitored by the doctor if there is any problem. This can be monitored by the patient himself. So any kind of such medical related ailments can be monitored very easily with the help of this kind of devices. Blood pressure levels can be monitored on a regular basis. We don't need to go to the doctor for that. There can be devices which can be attached to our body and which can monitor our blood pressure levels. There can be smart contact lens for detecting glucose levels. So this is a huge game changer because I mean I'll be talking about glaucoma also. Eyes and kidneys are the affected damaged organs that can be a result of lifestyle, that is long-standing diabetics can affect our eyes in a very big manner. We can lose our vision also. So for that, glucose levels detecting also can be done with the help of a smart contact lens. Again, the cost factor is a major domain here. We need to reduce the cost and we need to increase the efficiency. Implantable devices are there which is again a huge market. Out of 1 lakh startups, maximum are in the implantable devices domain, where small players have played a very important role in the healthcare domain. This is an ingestible pill sensor system. Now if suppose any kind of operation or any kind of detection had to be done in the stomach or any of the gastroenterology related ailments, then we needed to inject something inside and then try to, it was done through the leg, it was done through the mouth, etc. So this was quite painstaking for the patient and this was costly also. Now, this pill is called a smart pill, which can be injected inside the, you can just be swallowing the pill and it can, there is a sensor in that which actually transmits all the details and we can easily look at what is happening inside, or the scans can easily be retrieved on the mobile. And this is, again, this will be excreted outside. So there is no after effects or bad effects of this particular pill. Because this pill is going to be injected outside to the excreta. So this is something that can be a game changer going ahead. And a lot of advancements can be done in this also. Commercial wearable devices, as I told you, that mosquito-borne diseases, for that you can have some devices. Metabolic disorder, for this you can have some commercial devices which are very user-friendly. Skin diseases, you can have a lot of such devices which can treat that also. Or respiratory diseases, you can have wristbands for monitoring it or for taking corrective actions also if required. ECG also can be monitored. Skeletal system devices that can also be to improve your posture. Again, there can be smart shoes that can do that. So a lot of such advancements can be possible in commercial wearable devices case. Sleep or stress related. One more sleep related issue I'll discuss when we go ahead in the slides. Sleep or stress related disease. Again, that is connected with the heart here. So mainly to monitor the heart, we need heart rate variability and heart rate to be monitored. So there can be various devices for that. Cognitive disorders. For that, GPS related issues are there which can be monitored. Cardiovascular disease again can be monitored. Fitness tracking can be done. And now people are getting very much health conscious after COVID has was affected. So this can be done very effectively. Smartphone-based imaging systems are there, which can be used for medical, healthcare, biological, biomedical devices also can be combined here. So this can be a huge game changer going ahead. Smartphone is connected with all these. So what are required for us? In addition to the technology, we need camera, we need that screen, we need networking to be there, we need computational power that needs to be speeded up. So again, here the challenge is, can we have the computation speed at a higher speed with a lower cost? So higher configuration at lower cost. So that is a huge challenge. Motion detection related movements should be detected. So we need devices for that. And audio needs to be detected. 3D or depth related details should be available, and wearable devices. So these are all the combinations we require for this kind of a smart work to go on. As I told you that these are, I mean, we are covered. I mean, if I just go to any kind of person who is using smart uh, devices, we'll find that almost all the things are smart. We will not find anything which is normal, starting from the spectacles, smart glasses, to smart ring, to smart finger, to smart bracelet, to smart belt, smart pants. Everything is smart. The only problem is human beings are not able to cope up with these smart things. They are the same. Their behavior remains the same. But we can manage that also, because there are some work going on in that domain also. Sweat analysis. Now this is a new thing. Now sweat analysis, there can be variable sensors for biochemical sweat analysis. That means once your sweat is analyzed, you are sweating, that sweat is captured, and that diagnosis is done whether you have been affected by some disease or not. So that sweat normally is very good, but there can be excessive sweat that can lead to a lot of problems. So this can detect what kind of sweat analysis is there in your case. So these are some things which we are looking at, and this can be game changers for the future. Such devices are required at lower cost and with higher efficiency. As I told you that my main research area is AI in medical imaging. So this is a huge domain. Again, this is the organized domain where we are talking about a CAGR of growth of close to 40% by 2031. But this is organized market in India. A lot of unorganized players are there, and this can be very huge in India. It can be close to 60 to 65% CAGR. Can now this is one more area where cancer detection is one big area of research that is going on. Now, can AI help in cancer detection? So there was an experiment conducted wherein a radiologist, Ismail Paris Turkey, he is an MD and radiologist with 15 years of experience. He was asked to outline the areas where he he understood from the image where cancerous prostate cancer related growth was there. So he detected that area, and on the other side, an AI-based computer program was given the same. They have done the same, and somewhat matching results are there. So they are identical results over here. So this is again a very good indicator that technology-driven uh, movement can help in healthcare industry also. AI in cancer imaging can also be used in a big way, and they can be asked. Such questions can also be answered, like what a surgeon is doing, what a cancer specialist is giving answers. Similar answers can be given by AI program. Is it cancer or a harmless lump? If it's cancer, how fast it is going, how far it has spread, or somebody have already been operated for cancer. Or is it again going back after treatment? So all these kind of questions can be asked with very good speed by AI. Now again, this speed needs to be improved. That is what is the challenge. Improving the speed, accuracy, and reliability. Right? So we need to emulate that doctors can go wrong, but human beings, being a human being, but we don't want AI to go wrong. So that is something which can be a huge research area going on. Early detection of cancer, I mean, can we predict breast cancer 5 years in advance? So that is something which I think so is going to be the future research areas. For that, a lot of tools are there, a lot of claims are there, but still we have not been receiving accuracy up to the level that we should reach. So I think so this can be a big game changer if this is done. As I told you, this can be there can be disagreements, but radiologists or experts are there, but we need to be supplementing them with a lot of such kind of AI programs. Now, diabetes and diabetic retinopathy. This is an area where huge work is going on. 2015 to 2040, I'm expecting that 642 million people may be diagnosed by diabetes by the year 2040. So this is going to be a huge area due to lifestyle related disease. Because we are having a sedentary lifestyle, and so BP, sugar, all these ailments are increasing. And diabetes, long-standing diabetes, can be very detrimental to the health of the uh, public. So this is one area where I think a lot of research needs to be done. A lot of challenges are there. A lot of growth is there. Now, I would like to say here that one of the experiments conducted in Madurai, there is a hospital called I forgot the name, but there is a hospital which is being operated. It is the most record surgeries being performed in a day, cataract surgeries. So that hospital has relevant features, and Google's medical arm. This has actually tied up with that hospital in 2018, and they have provided solutions for providing this kind of treatment where Google has developed an algorithm which is having machine learning algorithm which is having 98% accuracy in such experiments, such treatments. So this is again Madurai, a local hospital tying up with Google, a big way. So this is the advantage that we are having in the healthcare industry. Big players can be supplemented with small players and they can collaborate and form good domains. So 93% of people affected by glaucoma were undiagnosed in the early stage of the disease. So that was the reason why glaucoma is not cannot be retractable. अच्छा, मेरा कभी online, बारह. So WHO estimated that 64 billion people were living with glaucoma, and that will increase to 95 million by 2030. So this is what we are talking about. This is the kind of growth in the disease that we are talking about, and these are affected at an early stage, and this can lead to a lot of problems going on. Now, what are the health diagnosis mechanisms for detecting glaucoma? First is tonometry, which is a pressure within the eye of the patient. Optical coherence tomography, these are all technical terms which are medical terms which are being used. Retinal nerve fiber layers around the optic nerve which are affected. Ophthalmoscopy, which is again one medical term. Perimetry, which is a visual field test around the perimeter of the eye. Gonioscopy, which is an intro ocular fluid outflow drainage angle, which is actually there. So all these are very important parameters for detecting glaucoma. So coming from healthcare to agriculture, now this is one domain where I think so a lot of challenges are there because in India, particularly, agriculture is a domain where we find that some issues are there. Like suppose if I say that when we look at image processing in agriculture, then we find that AI, image processing, robotics are not being used that much in agriculture as it should be used. Because we are talking about smart farming. If we are talking about smart farming, then I believe if we want 2030 at least 100 smart villages, then they should all have smart farming being done. Now, I was invited as one of the panel discussion speakers at one of the colleges in Hyderabad, and it was basically how to implement smart farming in India, technology's role in smart farming. So I was joined by a lot of people, out of which one IBM related scientist was also there. He talked about one experiment which was done in Bihar in the lockdown, where he was actually uh, in that particular village. It was standard that due to in his village due to lockdown. And IBM told him then that you can conduct an experiment over there on the smart farming, and that was done. Now, when the smart farming experiment was done, at that time the crop loss for the farmer was 20,000 rupees. The farmer was incurring loss, but still he used to do because that was his profession. Now, with the help of smart farming, including introducing sensors and all that, when ultimately after 6 months the crop was evaluated, it led to 80,000 profit on a small land. If the land is more, the profit would be more. So this kind of an experiment was conducted, and it was very much lucrative for the farm from the farming end. So this is the crop field, whether it is potato, citrus, apple, tomato, anything. Image is acquired. Leaf images of the data set are fed. Image pre-processing is done, and based on that, urgent. जी, ठीक है, आज करो। सर, सर वो डेटा आपको मिलता है, सारी चीजें। So there is image processing in agriculture, which is going on now. This image is acquired. Once the image is acquired, the leaf image data set is there over here. Uh, Based on that image pre-processing, and we are trying to detect whether the leaf is healthy or not, plant is healthy or not. So this requires images, high quality images, so which requires high quality image capturing mechanisms, and also AI to good effect. So this is what we are talking about. Image processing techniques in farming. Again, here robotics is being used here. These are robotic arms being used for all kind of weed detection to weed collection. Everything is being done totally using image processing. Plant diseases detected using satellite images. Now, these are some of the smart plant diseases which are detected using satellite images also. So again, AI can be very fruitful for this when it's combined with satellite imaging. There are enormous data sets for plant disease detection. These are some of the data sets if you want to use it for your day-to-day experiments. Also, you can use them. CoreSat is one of them. Vegetation whole globe products is one of them. IP Tracks is another one. EgyptSat is one. SUDFA is another one, and BANSAT is another one. So here we have a lot of enormous data sets for this plant disease detection. Now, how satellite imagery can be used? It can be used for mineral deposits as extraction. That is, at various places, mineral deposits may be there, but it may not be evident directly. So that can be done. Disaster mitigating plan and also recovery. Volcano and hazard monitoring can be done. Agriculture related work can be monitored, and biodiversity conservation can be done. Uh, Forestry and fishery harvesting can be done. Seismic risk assessment before any kind of earthquake comes, some kind of assessment can be done. So this is being done by a lot of scientists all over the globe. Forest carbon flux estimates. So a lot of use cases are there. I'm not going into all of them, but yeah, a lot of use cases are there, which can be very much productive if satellite imagery is connected with AI. Military use cases are also there, image processing, which we have already seen. Small target detection and tracking, missile guidance can be there, vehicle navigation can be there, wide area surveillance can be there, and automatic or aided target recognition can be there. So these are some of the image processing military use cases that I do. Smart parking system, as I told you that this is one small model which I have taken from one of the papers which I have given here. But there can be different kind of suggestions, different models, different uh, kind of dimensions which can be attached to this, and you can look at it from different angles according to demographics, and we can look at this in a big way. So this is basically where image processing can be used in smart parking system. Smart parking would be required whenever we go for a smart city solution. So this is, I think, so something which we are looking at a big level. And a lot of research can go on to this because this is a huge problem being faced by most of the cities. Floor selection, again, if it can be done very effectively, then the smart parking can be done easily. This is again smart parking. You can see what all is the location, and that this can be easily available at your fingertips, so you can decide where to park your vehicle, what are the options available. So this is a map description of the parking that is available and that is occupied. So green ball will show the path to your parking lot where you need to park. So there are no accidents, no problems as far as parking is concerned, and organized parking is taking place. These are smart image processing solutions, Industry 4.0. You don't need to actually change. You can easily use AR, VR to good effect, and digital twins are also being used. So you can use technology to good effect over here, and you can have smart imaging solutions. Fabric defect checking can be done. Again, this is basically used for textile, where one of the projects we have done was working on that also. That in the textile domain, we are having a lot of defects which are detected in the textiles, and if, many times they are not detected by the naked eye. So we can do the same as what I have suggested in the tiles. Same kind of logic we have used for this also, and we have used it in fabric defect checking. So some of the steps that we have taken in image processing activities here. This is what I was talking about. This is the data. Building is there. 3D design docs of the building is there. Now, if it is combined with sensors and real-time operational big data available, plus machine learning algorithms, then we can have a digital twin building which is formed, which can lead to a lot of issues. So improvement of building operations and use cycle, predictive maintenance, what if analysis, everything can be done on a digital twin of the building. So digital twin of the building can become where you can explore the building from different dimensions, and you can just look as if it is an actual building. So, I mean, I just have a short meeting, so I need to conclude my presentation over here. But I'm open to questions. Maybe 5-10 minutes we can have question answer session. Yes, any questions? You can unmute yourself and ask. Yes, Shifa, I think so has some question. Shifa, she have. You can unmute and ask. Yeah, currently some of the projects that I'm working on is regarding the fabric defect checking, and one of the project is in healthcare, and another is in education sector. So these three projects we are currently working on. So if anybody has some kind of an issue or some suggestions or some kind of area where they want some guidance, I'm open to
Sir, one question. In fabric defect detection, you are working with plain fabric or in printed fabrics? In printed
No,
fabric,
actually, plain fabric it's easier, but printed fabric it's very difficult because the defect checking. I mean, we require a lot of image precision detection of any defect in the during the printed any fabric because there I think so the algorithm complexity is more. So I'm working on that domain only. We have right now clocked accurately close to 96% accuracy. We want to increase it to 99 as close to 100 as possible. So that is a big challenge and we are working on it right now.
sir, one more question. What are the database for a fabric defect detection problem data set available?
Actually, we have taken real life data from fabric because in Gujarat, Ahmedabad, it's a textile industry. So, I mean, it's famous for textiles. So, I have taken that from a lot of textile industries. We have contacts and we have taken the data from them. So, it's live data. But data sets would be available. I think so. If you search, you'll be getting data. Or if you give me some time, I can come back to you with the data set.
Okay, sir. Thank you.
The only challenge right now is that students, I mean, I believe all over India in different colleges, students are not that interested in research. They are BTech students in particular, or any kind of master students also, until it's part of their curriculum. So bringing them into this research domain is very important because they need to
Okay,
look at
okay, because
problems.
okay.
They need to look at problems, and we need to take them to the field, show them the problem so that they are motivated to solve it, and then probably we can bring the solution. And that is where actually, as faculties, our role is very important. Yeah. Any other questions? I think so. Somebody is unmuted, and if they have no question, they can mute themselves.
Sir, if you have no question, can we wind up the session, sir?
Yes, ma'am. Thank you very much for inviting me. And I just share my email ID in case if anyone has any kind of projects for collaboration also, we can contact or any query also they can contact.
Okay, sir. Thank you so much for the great session, sir. Thank you.